Hi all! In this video you will learn how to find the equation of a circle using vectors. You may have already seen the equation for a circle, but using vectors to derive the equations might give new insights on these formulas. Let us begin with the formula for a circle. A circle is the set of all points at the same distance r of its center AB. This distance r is called the radius. As we have a mathematical expression for distance, we can translate this sentence into a formula. The norm of a point xy minus the center AB equals r. Writing out the formula for the norm, or length of a vector, we obtain that the square root of x minus a squared plus y minus b squared equals r. So we don't like square roots, we square the formula to obtain x minus a squared plus y minus b squared equals r squared. In this formula, you should realize that a, b and r are fixed and determine the circle, whereas x and y denote the coordinates of any one of the infinitely many points on the circle. So examples are x squared plus y squared equals 1, where the center is the origin and the radius is 1. Here, a point xy is on the circle exactly when the equation is valid if we plug in those values for x and y into the equation. So 1, 0 is on the circle, as 1 squared plus 0 squared equals 1, but 1, 1 is not, as 1 squared plus 1 squared is not equal to 1. Another circle is x minus 2 squared plus y minus 3 squared equals 8, which passes through 0, 5, as minus 2 squared plus 2 squared equals 8, but not through 3, 1, as 1 squared plus minus 2 squared is not 8. In the standard form of the formula for a circle, x minus a squared plus y minus b squared equals r squared, you can easily read off both the location of the center AB and the radius r. So expanding this formula is usually a bad idea. It makes it less clear what circle you are using. However, sometimes you get a formula like 2x squared minus 4x plus 2y squared plus 8y plus 1 equals 0. And you wonder what this represents. And an equation like this represents a circle as it only contains terms of the form x squared, x, y and a constant, and the coefficient in front of x squared and y squared is identical. To rewrite this equation in standard form, you can use the technique of completing the square. You do this once for the x coordinate and once for the y coordinate. For the x coordinate, you consider the x part, 2x squared minus 4x. We want to write it as 2 times x minus a squared plus c for some values of a and c. The 2 in front of the x minus a squared is of course the 2 from 2x squared. Indeed, if we expand 2 times x minus a squared plus c, we obtain 2x squared minus 4ax plus 2a squared plus c. So minus 4x must be equal to minus 4ax, and a equals 1. But then c must be minus 2a squared, which is minus 2. Thus, we can replace 2x squared minus 4x by 2 times x minus 1 squared minus 2. Can you now complete the square for 2y squared plus 8y? That's right. 2y squared plus 8y equals 2 times y plus 2 squared minus 8. Thus, we find that x squared minus 4x plus 2y squared plus 8y plus 1 equals 2 times x minus 1 squared plus 2 times y plus 2 squared minus 9. In particular, the equation can be rewritten as x minus 1 squared plus y plus 2 squared equals 9 over 2. The center of this circle is thus 1, minus 2, and the radius is the square root of 9 over 2, which is 3 over 2 square root 2. That's all for now. See you after practice.